Hello and welcome to our first real lesson of chemistry. So today we are going to introduce this study of chemistry. We're also going to look at what's called the particle theory and classification of matter. In grade 9, we actually shorten this to the PZAM method, much more fun to say, and it's an easy acronym for you to remember what the particle theory actually is. So before we get to particle theory, let's actually talk about what chemistry is. So this is our first branch of science that we study. I'm impartial. I love chemistry. We all know that. Before we talk about chemistry, let's talk about what science is. So a great definition of science, it's a way of knowing or thinking about nature. So it's a way that you can actually observe nature or the world around you. It's going to depend on observations, explanations, logical arguments, and skeptical review. So essentially, if you are doing science, you're going to make observations around you and you're going to ask the question, why? You're then going to try to answer that question using observations, exclamations, and you always want to have skeptical review. So you always want to ask why, and you want to withhold judgment until you've actually made those measurements. So there's lots of branches of science we're going to study for this semester. We're going to look at chemistry, biology, physics, and we're going to study earth and space science. Our first branch is going to be chemistry, and in chemistry, it's a branch of science that studies structure and properties of matter. So this word is really important here. So anytime that you think chemistry, I want you to think about this term, matter. Now the big question is, what is matter? So let's give up a definition of matter. Matter has two components. It's anything that takes up space and anything that has a mass. So in order to determine if something takes up space, we're going to measure its volume. You might remember this from elementary school. So volume is a way to measure how much space something takes up. And mass, this often has to do with the term weight. So weight's actually an incorrect term. Weight uses gravity in it, but it's a simplification. So mass might be you stepping onto a scale and seeing how much you actually weigh. The particle theory, that's what we're going to study today. The particle theory is the scientific model that explains matter. So essentially, it's rules that all matter must follow. So if something takes up space and has a mass, it's matter, and then that matter must follow the rules of particle theory. So let's dive right in and let's look at the particle theory of matter. So these are all points that all matter must follow. And in class, I'm actually going to use some demos to prove these to you. So the first part of particle theory is our P. And what P stands for is that all matter is made up of very tiny objects called particles. We're actually going to try to describe this unit, what those particles might look like and what they might be called. Between those particles, there's also spaces. So these particles aren't all connected together. There's actually spaces within these particles. That's what the S stands for in PZAM. The particles in a substance attract one another. So there's some form of attraction between these particles. The amount of attraction that you see actually changes. Sometimes these particles are very loosely attracted to each other. Sometimes these particles are very strongly attracted to each other. We're going to look at that in a second. And the particles are always moving. So again, they're always moving. Sometimes they're moving very fast. Sometimes they're moving very slow, but they're always moving to some degree. So these are the 4 points of particle theory. P, meaning that everything is made of particles. S, meaning there's spaces between those particles. A, meaning that those particles are attracted to one another. And M, meaning that those particles are moving. So based on these 4 points, we actually see 3 different states of matter. We see solid, liquid, and gas. Some of you might be yelling out that there is a 4th state. You're right, there is a 4th state called plasma. We don't technically study plasma because plasma is very high energy. You're actually really never going to see plasma probably in your lifetime. There's actually more than just 4 states of matter. Scientists have now classified up to 128 different states of matter. That being said, most of them you don't see. They're very, very strange conditions, sub-zero conditions. So in your everyday life, you are likely going to see 3 different states of matter. Let's talk about our first state of matter, and this is going to be our solid. So if you're dealing with a solid, I'm going to zoom out just so you can see this whole thing. If you're dealing with a solid, the particles in a solid are tightly packed and they have very strong attractive forces. So I want you to pick something solid right now. I'm going to pick this table that's right in front of me, and I'm going to push down. By pushing down, you're actually not able to indent that solid at all. It's because the particles within that solid have such a strong attractive force. So they're so strongly attracted to one another that even when you push down, you're not able to move them because the force is so strong. They're said to have low energy. So particles in a solid have low energy. That means they're not really moving very much. They're still moving. What they're doing is they're vibrating slowly back and forth. So they're still moving, but they're not moving a lot. So you don't really see them flow, right? A solid doesn't flow. A solid just stays as it is. So we call this a definite shape. So solids have a definite shape. So I can take something that's a solid, I can place it down on the table, and it's going to stay the shape that it was when I placed it down on the table. Solids also cannot be compressed, so that means that I actually can't squeeze a solid and change its shape. Liquids are the next state of matter. So in liquids, we're not as tightly packed. Liquids are further apart. So you can't walk through a solid wall, but you can walk through water. A little bit of resistance, but you can walk through water. That's because these particles are further apart, and they actually have less attractive forces. So again, you can't push through a solid wall, but you can push through water. You get a little bit of pushback. That's because these particles are less attracted to each other than they are in a solid. They have higher energy, so they're moving a little bit faster. Because their particles are moving a little bit faster, you see that flow, right? So you actually see a flow. It's because the particles are actually moving through in a liquid. They have an indefinite shape. So if I took a glass of water and I poured it onto the table, it's not going to hold the shape. What's actually holding the shape of a glass of water is the glass, right? The actual container is what's defining the shape. And liquid actually cannot be compressed. So when you actually try to push on a liquid, it might move, but it's not actually going to be compressed. Our last state of matter is a gas. In a gas, the particles are the furthest apart. So in a solid, they're closest. In a liquid, they're further. And in a gas, they're furthest apart. So particles are actually very far apart in a gas. They have the highest energy. So in a gas, you actually see the particles are flying around really fast. They're bouncing off the walls, which is good that they're not close together, right? So they're colliding with each other. They again have an indefinite shape. So let's think about the gas that's in a balloon. The reason it's got the shape of a balloon is because of the actual balloon itself. As soon as that gas is released from the balloon, it's going to have an indefinite shape. Gases actually can be compressed. So liquids and gases are similar, that they both have indefinite shapes. Liquids cannot be compressed. Gases can be compressed. Now, one thing that a lot of students confuse is that they think that states of matter are fixed. So they think that everything that's a solid is always going to be a solid, everything that's a liquid is always going to be a liquid, and everything is a gas is always going to be a gas. That's not true. The particles can actually change. The particles that are within whatever substance you're looking at, by you actually adding energy, you can change the state of those particles. So the particles themselves will not change their chemical makeup, but you can change if something is a solid, a liquid, or a gas by either adding energy or taking energy away. So why does water always look liquid? Because we typically see it at room temperature. You can actually take energy away from water and you can make it a solid. Ice, right? So if you take energy away, if you chill a liquid, you can make it a solid. And you can actually add energy to water and you can evaporate it and form a gas. So the reason I talk about water is it's because it's something that you can see it changing from a solid to a liquid to a gas. Some energy changes are so big, you don't tend to see it. For example, if you're looking at a metal, like in scissors, it's always going to look like a solid. I can add an incredible amount of energy to that metal and melt it, turn it into a liquid. I can add even more energy to that metal and turn it into a gas. Because it requires so much energy, thousands of degrees, you don't typically see it in everyday life, so you don't think about it happening. So let's look at these state changes and see how much energy is required to lose or gain this state. So we are going to start with a solid. So we're going to remind ourselves that in a solid, particles are close, they have a strong attraction, and movement is very little. So they're just vibrating back and forth. Now let's take a look at what it takes to go from a solid to a gas. You can actually make that change. It's a big change, but you can make that change. So to go from a solid to a gas, your particles are then going to be very far apart. They're going to be moving rapidly, and the forces of attraction are going to be almost zero. So you're going to take very tightly packed particles, and you're going to add so much energy to them that they start zooming around real fast. They move apart. They're bouncing off the walls. And then you can actually change from a gas to a liquid as well too. By going from a gas to a liquid, you're actually slowing those particles down. So gas particles move quickly, liquid particles move slower. You can also change from a liquid to a solid by slowing the particles down even more, or you can change from a solid to a liquid by speeding up the particles. So you can see that any change is actually possible by either slowing up or speeding down those particles. We have specific names for each of these changes. So let's take a look at what the name is to go from a solid to a gas. This is a pretty big energy jump, so you don't typically see it unless you're in a lab. But to go from a solid to a gas, we call this sublimation. If you want to go from a gas back to a solid, this is also called sublimation. It's the only time that the name is actually the same. To go from a gas to a liquid, we call this condensation. So think about condensation. You often think about wet, like a water bottle. So sometimes you'll actually see the water droplets forming on the outside of a water bottle. That's condensation. What's actually happening is that cold beverage, that cold water bottle is actually taking the water vapor from the air and turning it into a liquid that's sticking. So condensation, you think about wet, that's because you're going from gas to a liquid. Evaporation is what's called when you go from a liquid to a gas. So you often think about puddles evaporating. What's happening is the liquid in the puddle is actually getting energy added to it, and it's becoming water vapor in the form of a gas. To go from a solid to a liquid, think about melting. Think about melting ice. To go from a solid ice cube to a liquid, you're going to melt. And then to go from a liquid to a solid, you're going to freeze. So if you want to go from liquid water to solid water or ice, you're going to freeze it. So those are the different names for the state changes in state. You do want to know them. And the other thing you want to think about is heat being added or removed. So in order to melt something, to go from a solid to a liquid, you want to add heat. In order to go from a solid to a gas, you want to add heat. And in order to go from a liquid to a gas, you want to add. So essentially, any time that you're going from a lower state of energy to a higher state of energy, you want to add energy. A liquid to a solid, you're removing energy. A gas to a solid, you're removing energy. And a gas to a liquid, you're removing energy. So essentially, anytime that you want to go to a lower state of energy, you have to take that energy away. There's lots of different ways to do that, but typically in everyday life, you're going to be adding heat, so you're going to be heating something up, and to remove energy, you want to cool something down, you might use a fridge. So those are different changes in state. When we talk about physical and chemical changes, we are going to come back to these. Have a great day, and we'll see you soon. Bye.